And this is an important webinar for us as we listened our users during the years and collected feedback. What features would be interesting to have in the Galera cluster? And as a result, we now release Galera Cluster 4 for MySQL 8. Well, actually, we released that a couple of weeks ago, but we call this is a release webinar. However, having said that, MariaDB, our main certified authorized partner, did have Galera Cluster 4 in MariaDB almost 1 year ago. So they did this already 1 year ago with us, but now we are with the MySQL 8. And today's presentation will be given by Colin Charles, and I'll give the mic to Colin now.
Thank you very much, Sakari, and thank you all for attending today. We have quite a bit of things to talk about in terms of new features. So we will sort of dive right into it. So this is the agenda for today. Basically, we're going to focus a little bit on Codership. What is Galera Replication? Galera 4 for MySQL 8. A comparison of the offerings that come with that you can get Galera 4 in, and as Sakari just mentioned, you can get that actually in in MariaDB server 10.4. You can also get it inside of Percona server, Percona XDB cluster. So we're going to talk a little bit about those as well. General conclusion. There obviously is going to be no demo today in our 50 minutes. We are instead going to put more resources into the Galera library, where we make videos of installations, upgrades, and so forth. And we've had questions about rolling upgrades. So again, galeracluster.com/library. It's a very good resource if you haven't already been there before. So we don't only have videos there, we also have articles and more. So Codership are the original makers and engineers of Galera Cluster, which is a multi-master synchronous replication solution for the MySQL ecosystem. If you happen to ever use Percona XDB cluster or MariaDB Galera cluster, where MariaDB has had it built in for multiple years now, you are really directly benefiting from the work done by the team at Codership. So beyond engineering, you can also purchase 24/7 support, training, consulting, and a whole lot more. You can contact our friendly sales consultants to help you find your Galera cluster solution. We're always here to help. Codership truly are the developers and experts of Galera cluster. This was established in 2007. 3 founders, all engineers, and they're all still around, which is extremely important because this is, not something you often see people having conviction building technology for over 13 years. Company as services business model, producing open source software, and we've had thousands of users in various industries. So there is basically no industry where there is no coverage of a Galera cluster user today. They're in extremely high availability environments, typically like in the gaming space, banking, healthcare, SaaS businesses, and so forth. So what is Galera Replication really under the hood? It is a generic replication plugin for database servers, which basically means that it just needs a replication API, and it can interact with the database management system. And the API we affectionately call wsrep is known as write set replication. The database and Galera plugin, of course, need to have the same writes replication API version. This one's important, especially since we're talking about Galera for today. But let's not forget that there's still Galera 3, which has been around for quite some time and is extremely popular. By being a generic replication plugin for database servers, it's also important to note that we could plug the writes and replication API into other database backends as well. But we've just chosen to work with MySQL and the entire ecosystem that surrounds MySQL today. So there are, of course, several types of replication in MySQL. You are probably already familiar with asynchronous replication, in where it is very fast. There are just no guarantees that the secondaries receive a transaction, and you may also have lagging secondaries. Typically, what happens is you insert into a primary, and then it will potentially go to the secondary immediately, or with some kind of delay, depending on if the primary is too busy. This one doesn't come with automatic failover, so you need a framework, and naturally you need obviously more than that to also bring failback and so forth. Also, semi-synchronous replication, in where when you make an insert into a primary, there is a guarantee that that has to go to at least one secondary, and that's what semi-sync is. And in MySQL, it is available as a plugin. In MariaDB, it is built in by default. You still do need a framework to handle failure and failover. Then there's, of course, the synchronous Galera cluster, which we'll obviously here to talk about today, in where you can make inserts, and there is no concept of a master, primary, and a secondary. All nodes in a multi-master replication cluster are equal. So when you make an insert, let's say you make a connection into node 2, when it's time to apply the transaction, it applies it to node 1 and 3, and you either get a commit or a rollback. And you don't need to have any kind of framework to handle the failover or any kind of failures. Because if a node goes away, that's not a problem. The infrastructure continues running as is. So Galera cluster multi-master application, it looks like one very large database with multiple entry points. In this particular example here, we have 3 nodes. So you always do need a 3-node minimum, and we'll talk about that in a moment. But your application just needs to have 3 IP addresses, and your application will happily do reads and writes without issue to any of the databases that it manages to connect to. Galera, of course, supports automatic node provisioning. What this means is after you have bootstrapped the first node, the second and third node don't need to start in a bootstrap mode. They can join the cluster automatically as long as the my.cnf configuration file enough information in terms of an IP of where to connect to. Each node, obviously, as I said, has identical data. And I think that's really, really important because you are replicating the data across all nodes. Transactions are processed locally until commit time, then replicated across all the nodes throughout the cluster. Each transaction is immediately replicated on all nodes at commit time, and there are no stale secondaries. You can read from and write to any node like a typical multi-master cluster, and there is automatic transaction conflict detection. Your data is replicated equally across all nodes, so new nodes can join automatically without issue. There are data consistency protections such that you can avoid reading stale data, and of course, it'll prevent any unsafe data modifications. And in today's world, Galera runs perfectly in the cloud or any kind of wide area network. You can have nodes on different continents. You can have end-to-end encryption turned on. And there have been so many optimizations done to ensure that you have communications over a wide area network with the least latency possible. because remember, you want to write, the more nodes you have to write to, obviously there is an increase in commit time, and we want to make sure it's done in the most efficient way as possible. So people often ask how many people use Galera Cluster, and we can't give you one definite answer, but we can tell you that MariaDB server in 3 years ago stated they had over 12 million downloads. Percona has stated some time ago they have over 1.3 million downloads of PXC. We also have a lot more from GaleraCluster.com, and we also can't count the distributions that include MariaDB as well as Galera Cluster. We see lots of cloud platforms recommend Galera Cluster for high availability usage. And we also see thousands of users in various industries trusting Galera Cluster for over a decade. We've won a MySQL Community Award, and it is included in many mainstream distributions, and we also support many mainstream distributions. So Galera is all about multi-master replication. We really do have high availability with no data loss, consistently available reads data across all nodes. There is no single point of failure. It's highly scalable. You can add or delete nodes on the fly. And it has quorum-based failure handling. This is why we require a minimum of 3 nodes or an odd number of nodes, because when one node of a 3-node cluster goes away, you still have 2/3 of a cluster left, and the quorum algorithm will say the cluster is still healthy and you can continue running. If you only had a 2-node Galera cluster and one happened to go away, that would only have 50%, and that's not a majority quorum, and that would lead to a failure in the cluster. Also using optimistic concurrency control, which means the transaction is processed locally on the node, and when it's only time to commit, does it get applied across other nodes? And then you either get a commit is okay, or you end up getting a rollback if required. And we have ways to help you mitigate these rollbacks, because we can retry things on commit. It is 100% multi-master cluster, so there is no such thing as a lagging secondary. This is a feature of the product by design, and it is not some afterthought that was added on to it. There's also parallel replication, so you can have any number of secondary applier threads started, and the secondary control is on a row level, so that it will apply in parallel with commit order being dictated, so that you can ensure that your database is ACID compliant as well. And the bonus of not needing automatic failovers via framework, not designating single nodes for writes and the rest for reads, keeping the configuration very simple. Everything is just kept in your my.cnf, and you can have very good scheduling of any kind of scheduled downtime and so forth. So overall, I'd say Galera is extremely easy to get set up with and utilize. Galera is optimized for the cloud. We only have a very optimized network protocol, and we only exchange information across the WAN upon commit time. So if you have a data center in New York, another one in London, another one in Singapore, if your application is happening to write in New York, when it's time to commit, say to all the nodes, it writes to 3 nodes in New York, 1 node in London, and 1 node in Singapore. And that's only a 5-node write upon commit time. We do topology aware replication, so that we only send a transaction to the data center once. So you can actually segment your network to ensure this happens. We detect and automatically evict unreliable nodes. So if you have a flappy network or some kind of node failure, it doesn't actually rejoin until you do manual intervention, so that we don't want unreliable nodes coming back, either doing incremental state transfer and then going off, or doing a full snapshot transfer, because then it blocks another node and then goes off again. We don't encounter split brain situations with Galera Cluster, and we can definitely encrypt traffic, which is definitely key in a cloud-based environment. that you may end up using. So a little bit about the ecosystem and the writes and replication API versions. GaleraCluster.com is what I consider the upstream for Galera Cluster. It started with binaries available for 5.5, 5.6, and 5.7. 5.5, for what it is worth, MySQL 5.5 has been end of life for some time now. So there is no real support from anybody for 5.5, realistically speaking. So that leaves 5.6, 5.7 with the write and replication 3 API. There's also the write and replication API 4, which is what is available in 8.0. Percona HTTP cluster is similar because it's also based on MySQL. And they have writes and replication API version 3s for 5.5, 5.6, and 5.7, and version 4 for 8.0. MariaDB has been a fork of MySQL since 5.5. So that leaves 10.0, 10.1, 10.2, 10.3 following the writes and replication API v3, and 10.4 using the writes and replication API v4, which is Galera 4. So there are 3 distributions, 1 upstream, 2 branches, and a somewhat varying feature set. But today we are celebrating and obviously launching on the with the webinar the version that comes from GaleraCluster.com, which is Codership, the founders, creators of Galera Cluster. In terms of replication versions, there have been many major releases, 1, 2, 3, and 4. The current production head for Galera 3 is 3.29, and the current production head for Galera 4 is 4.5. There have also been many write and replication API versions. Current major version is at version 26, which corresponds to Galera 4, and 25 that corresponds with Galera 3. And if you do have write and API changes, you do need to perform a rolling upgrade. This means that there's no such thing as mixing a Galera 3 and a Galera 4 node. And if there is a write and replication API version bump, say from 29 to 329 to 330, you are obviously advised to do a rolling upgrade and upgrade. Ooh, that's weird. Okay, so Galera 4 and MySQL 8. We've released the most up-to-date version of Galera 4 with MySQL because we have 8.0.19. The current release version of MySQL is 8.0.20. The closest that Percona has at the moment is 8.0.18. So we have all the features of 8.0.19 with Galera Cluster 4 that was made GA a little while ago. It comes with write and replication API 26 and the Galera 4.5 library. Write and replication is integrated into the release that MySQL 8 is shipped, and you can download and use it now. So I highly recommend you try it and give us some feedback. Tell us how much you enjoyed upgrading, or if you found a bug, let us know, and so forth. So here's an overview of features, right? So we have streaming replication, group commit support, improve foreign keys, network resiliency. And we have many slides that go through all of these as we go on through the webinar. Streaming replication is the base for supporting huge transactions. What is a huge transaction? I mean, we handle transaction sizes of up to 2 gigabytes before streaming replication came along. 2 gigabytes per transaction is actually very large to begin with. Where do you find use for such large transactions? And the general answer is if you're doing a very large load data in file, for example, ETL operations, loading data faster, that's what a large transaction would probably make sense for. With Galera Cluster 3, a transaction processes on the master node, basically the node that the client connected to execute the transaction until commit time. Nodes also process write sets in a single memory resident buffer. So basically for large transactions, write sets are too large and hard to process, which is why we have wsrep max ws size to prevent large transactions. Streaming replication is of course new in Galera Cluster 4, and it'll enable running transactions of an unlimited size in the cluster. You can still reject large transactions if you'd like, but we don't have that problem any longer. And this is all runtime configurable to make sure things work faster. So if you have a long running transaction or a very large ETL operation, and where you're doing a load data that is large, we can now, instead of using wsrep max ws rows and wsrep max ws size, we don't have to limit the transaction rows to 128 kilobytes and the transaction size to 1 gigabyte or a maximum up to a limit of 2 gigabytes any longer. We used to even publish guides on how you can handle large transactions using tools like PT Archive. Again, we're going back to the Galera Cluster library. And there was also a practical test showing you how large a Galera transaction could be approximately 5 years ago. Now with streaming replication, it can go larger. So how does streaming replication work? Basically, transactions are replicated in small fragments while the transaction is processing. This means there is no actual commit yet, but Galera is replicating a number of smaller sized fragments, which is what we call transaction fragmentation. And you can specify this, say you want it to be 5,000 rows, 1,000 rows, which means that every, say 1,000 rows, it gets replicated to the other nodes, but it doesn't get applied. So the size threshold, of course, is configurable. And these replication fragments are applied in slave threads that also preserve the transaction state in all cluster nodes. Fragments will hold locks in all those nodes, and they cannot be conflicted with later. So you can process write sets much larger than 2 gigabytes in size. And in the event of any conflict, of course, yes, there can be a rollback if need be. So when you want to configure streaming replication, and like many things in MySQL 8, this is also dynamic variables. There are two that you need to pay attention to. There is wsrep transaction fragment unit, which is the unit metrics for fragmenting, where options are in bytes, the write sets in bytes, the rows, the number of rows you're planning to modify, as well as the statements, the number of SQL statements that are going to be issued. There's also wsrep transaction fragment size, which is the threshold size in units when fragments will be replicated. By default, this is actually set to 0 because it means no streaming replication. But you're going to want to experiment based on your workload. And that's why these session variables are all dynamic. And we have a great way of monitoring this as well, which we'll talk about in later slides. Now, people often ask, does this come for free? Like, how does this magic just work? How can I suddenly apply to 5 gigabytes of transactions at any given time? And there is, of course, a lot more logging. So when you log, there's going to be more calls, more fsync calls. So your system's going to get busier. And there's also obviously elevated replication overhead, right? So we are going to use up your bandwidth regularly. The streaming replication will definitely cause degraded transaction throughput rates. But in terms of degradation, you're probably looking at no more than like 5% of what you were already getting before. So the best use case is still to use streaming replication to cut large transactions into size. And we, through experimentation, have seen that the fragment size of around 10,000 rows seems to be about right. Applications can also set streaming replication on and off on a need-by-need basis. Of course, you need to then change the application naturally because the application can then just control control the two options in a dynamic fashion based on a per session basis. We also decided that it would be a great idea to have some new metadata where we have rights replication tables inside the MySQL database. Why did we pick the MySQL database? For simplicity's sake, because one, if you use MySQL is invested heavily inside what is known as performance schema. But if you use MariaDB, they are invested more into information schema, and they're both available, but they have different kinds of things inside. So for us, in terms of simplicity, the MySQL database was probably the best one because we know that they all have the ability to have the MySQL database. And you'll notice that there are 3 new Galera Cluster system tables available now as well. So wsrep cluster is the first one that I'd like to bring some attention to. It contains the current view of the cluster, some identity information, and also the capabilities of the cluster. So let's go one by one. The cluster UID contains the unique user identifier of the cluster. The view ID corresponds to the status value of the right set replication cluster configuration ID, which is the number of cluster configuration changes which have occurred within the cluster. The view sequence number, on the other hand, corresponds to Galera sequence number associated with the current cluster view. The protocol version is the same value as contained in wsrep protocol version. It's the protocol version of the MySQL wsrep or the MariaDB wsrep patch. And then the capabilities column contains the capabilities bitmask provided by Galera. Its metadata will be needed to recover node state during crash recovery. Now, we have multiple ways of keeping node state when it comes to crash recovery. If you look inside your var lib MySQL or in data directory that you specified for GRA state.dat and GVW state.dat files. Now we also have capabilities inside of the table wsrep cluster, which will also tell you if you have recovery available. And we can turn these on via several options, right? So in your my.cnf, again, you could configure such that you could recover fairly easily. And this is like PC recovery as well as Gcache recover. These are not set to be turned on by default, but these are perfect options that you'd want to keep turned on, generally speaking. There is wsrep cluster members. Results of this example, you can see that this cluster is composed of 3 nodes being the minimum, naturally. The node UIDs are unique for each and every node. That is expected because they're all individual nodes that were created. You will notice that the cluster UID is the same for all 3, corresponding to the related value found in wsrep cluster table showed in the example earlier, because they're all part of the same cluster. Each node has a unique name. So in this example, we set it as Galera 1, 2, and 3, because they were named in the configuration file using wsrep node name parameter. The incoming node address is set to auto for all these nodes. But if you choose to set it individually to specific nodes with a wsrep node address or bind address, you could do this inside the my.cnf configuration file as well. But for all intents and purposes, I would recommend you just not touch that and let the node incoming address always be auto. Then there's the wsrep streaming log. So earlier we talked about streaming replication. And I said that you'd want to tune it based on how things are working. And what better way to do it than to use wsrep streaming log, because it basically contains metadata and row events for ongoing streaming transactions with write set fragments per row. So typically, when you do select star, you won't see any results since it will contain entries only for transactions which have streaming replication enabled. By default, streaming replication is turned off, and you can configure it at runtime. So you will not see anything unless you are already using streaming replication. And we also these write set replication functions, which we're quite excited about. You do need to change your application a tad bit. But once you've done that, you can actually use things like wsrep last seen GTID, which will return the global transaction ID for the last written transaction that the client observed. And wsrep last written GTID will return the GTID of the last written transaction made by said client. And wsrep sync wait up to GTID, which will be quite useful, will block the client until the node applies and commits the given transaction. So again, this is something you'd have to talk to your application developers about as a DBA, that these are functions that are available that one could use. Quite healthy functions. I'm sure that many of you use foreign keys, and because you're using InnoDB, and Galera has always supported foreign keys for quite some time. So yeah, when I say always, always means at least in the last 5 to 8 years. There have been generally no known reported bugs of foreign key support. And it's great to know that now right-side certification rules are also optimized to handle foreign keys. So if you've previously seen any false conflicts in certification logs, they will now basically disappear because, or have a tremendous reduction to it because we have optimized the way we handle foreign keys. We've also started working with a group commit code that is native, and we have natively integrated it with the MySQL 8 binary log. Now, we don't use the binary log by default because we have our own Gcache. However, the group commit code already exists and we might as well make use of it. So we have commit time concurrency controls to be reworked such that the commit monitor is released as soon as the commit has been queued for a group commit. Transactions are then committed in groups while respecting the sequential commit order. If you encounter poor network connections, now poor network connections is something that would definitely affect a Galera cluster because we really like you to have good bandwidth between your nodes. Now, if you have it all in one cloud provider, again, we'll pick on the largest one, say Amazon. If you have got data centers in New York and London and Singapore within the same service, you've got very good interconnects. But let's say you've also decided that you maybe want to use Google Cloud or Azure at the same time, and you want to split your nodes in other data centers. That's fine too. But we want to make sure that you've got very good connections. But now with Galera 4, we're definitely become a lot more resilient when it comes to handling poor network connections. So we can handle irrecoverable errors, and a node will always attempt to leave the cluster gracefully if it is not possible to recover from errors without sacrificing the consistency of data. So basically, data is sacrosanct with Galera cluster. You always want to make sure that the data is never corrupt in any way, shape, or form, and you protect the data. And if you can't protect the data, we'd like to ensure the node has left the cluster gracefully. So if you have a geo-distributed multi-master Galera cluster setup, so like a 9-node setup, we're completely ready for you with Galera 4. We do support rolling upgrades. So you can have an existing MySQL 5.7 3-node cluster. You could isolate a node. So if you have a 3-node cluster, you make one node read-only. Now you have a 2-node cluster for read-write. You shut down the server, upgrade it to MySQL 8, start again with another writer application provider, run the upgrade, shut down the server, start with the writer application provider library, and then allow read-only access to the server. Now you update node 2 as above, then you're now running a 2-node cluster. Then you need to shut down node 1, allow the read-write access again so that the node 1 upgrade is complete. Then you repeat again for node 3. So rolling upgrades are not as straightforward or automatic as one would expect, but extremely useful and handy. What is not here yet but will be coming? For one, it's worth noting that when it comes to encryption, logs are all completely encrypted with the exception of the Gcache today. That is the IB data, the reader log, and so forth. The Gcache has been able to be encrypted for at least 1 year now, because MariaDB Enterprise 10.4, which is not MariaDB Server, has had that ability now for some time. Now, I don't know if this feature ends up making it into 10.5's community edition, or at which point only will it be in MySQL 8 Galera 4. But we have the ability to do Gcache encryption today, and that's something to look forward to. X8 transaction support is something we're also likely to have within the MySQL 8 Galera 4 lifespan. Because we need it for this thing called a sharding cluster, where you'd have multiple shards backed by clusters. So this is something we expect will come later. Non-blocking DDL coincides with other work that MariaDB Server has been doing, as well as actually MySQL, to be fair. Lots of people want this, especially shared hosting companies, because today if you want to upgrade a WordPress database and you have, say, 1,000 WordPress databases on one Galera cluster, it basically locks all writes and all databases served on that cluster when you run the WP upgrade.php script. However, with non-blocking DDL, we'd only actually block that one WordPress database as opposed to the entire cluster. And cluster error voting is likely to obviously make its way into 10.5 and also MySQL 8. The reason why I'm talking about 10.5 is because it is fairly just around the corner. So let's do some quick comparisons with other variants of Galera 4. MariaDB Server 10.4.6, which Codership has worked very closely with throughout all these releases, was GA with Galera for 18 June 2019. So as I said, almost 1 year now. Percona HDB cluster 8018 was generally available at the end of April, so has been around for a little over a month. And then we've got Galera 4 with MySQL 8, and this is 8019 from Codership, made GA a couple of weeks ago, and maybe more importantly, also one release ahead of Percona HDB cluster. And I guess since we're all here, might as well tell you that I spent multiple releases, so we've had at least 3 alpha releases before this that we got to utilize. So the general consensus as to how one would do a PXE merge would be that the source would have probably come from MariaDB, ideally. And obviously things are much different with the Galera 4 with MySQL 8, where we ourselves maintain the source. Now, I can talk a lot about different features, like what features MariaDB has and what features MySQL has. But that would be in itself a 1 hour to 3 hour long talk, because MariaDB has an Oracle SQL mode and it can support sequences, whereas MySQL doesn't have that. But MySQL has things like a X protocol, which will allow you to connect to a different port and query things via MySQL shell. And it would be remiss for me to tell you that MySQL shell, of course, does not do anything in terms of configuring Galera. So I'm not going to go deep into all these MySQL versus MariaDB features, because there are plenty. But I will focus on the Galera aspects. And one thing MariaDB Server 10.4 has is the tight integration with backup locks, which if you were using for SSD full state snapshot transfer and you happen to use Maria backup, it'll just use a lightweight lock and handle the SSD. Very handy. Percona HDB cluster includes features that you'll be obviously familiar with in Percona Server, It also comes with additionally proxy SQL and lately as a Kubernetes operator. They have obviously got an encryption plugin that you get via Vault, HashiCorp Vault. MariaDB has also got an encryption plugin where you can use the Amazon KMS key management service. So that's, encryption, keeping the keys off the file system. If you find that something that's important for you, please don't hesitate to contact us. Then there's also a MySQL upgrade, which happens after an SSD. And the reason is not only is the server upgraded, but it's also the data dictionary keeps a version. And now it's best to and safe to run said upgrade after an SSD. And then there's also something maybe interesting in the sense that by default, Percona HTTP cluster actually comes with encrypted traffic by default, so PXT encrypt cluster traffic. This basically means that you don't get the ability to have any kind of unauthorized SSDs and so forth. Now, the reality here is we don't want you to have to put SSL certificates around because that's a tedious way to get set up. So we allow you to set up without SSL, but you can turn it on if you need it. And you should if you're running in a public cloud. And then, of course, extra backup is shipped by default. It doesn't have the same lightweight lock like Maria Backup does. And then the default files are a little different. For example, in Percona HTTP Cluster 8, the Gcache recover and the PC recovery are turned on by default, and they never were before. So, in summary, the developers of Galera Cluster really are Codership. And most developers of Galera Cluster are also at Codership. And the code is known way better than anyone else at Codership. If you're thinking about roadmaps and who can plan what comes into a next release of Galera Cluster, it's clear it's Codership. We also have a main partner in MariaDB Corporation, and we listen very closely to the community. So if you write on the Google group that you're a legitimate user, you've been spending lots of time with Galera Cluster, you've got several terabyte database, and maybe a 7-node cluster, and you want an audit plugin, these are the kind of people we totally would listen to from within the community. What's coming next? Some exciting stuff. For one, we have a maintenance release for 5.6 and 5.7. This maintenance release also includes Write Replication API 3.30, as opposed to 3.29, which is the current release now. And it does include a handful of fixes. So this you can expect within the coming week. We'll, of course, have and open up more features in MySQL 8, but there doesn't seem to be any urgency in that at the moment. But yes, it's definitely something we've talked about. So maintenance releases, Galera, a lot more features for MySQL 8. We're also going to be rolling out new management tools. That's coming probably also in the next couple of weeks. We have a GUI where we can allow you to deploy, manage, and configure cluster. And then probably again within the next couple of weeks, we'll see MariaDB release 10.5, which also includes Galera 4. I'm open to some questions, which you can ask in the little corner, and there actually already are questions. So let's take a gander at some of these questions. And let me see if we can answer them all for you. So currently I'm using 5.7. What is the best way to monitor writes and replication flow control, and what are the flow control improvements in Galera 4? That is a great question. And we haven't actually made any improvements in flow control monitoring today, but you can manage flow control basically by doing show status like writes and replication flow control, and you can also use the MyQ utilities, but we haven't actually made any changes to how you could look at flow control. So our documentation still very clearly states how you can handle this. If you feel like there are more ways that you'd like, feel free to send us some feedback. Why does Galera need a quorum if there's no role exchange involved? Well, it's quite simply because when you have a 3-node cluster and one node goes away, then you have a 2-node cluster, 2/3 cluster still remains running. Now, when the 3rd node comes back again, it comes back as a joiner node, and it has to block a donor node from doing anything to it, because the donor node now has to send over these transactions that were missed either via an incremental state transfer at IST or a full state snapshot transfer at SST. Now, if you only had one node remaining and that happened, then your application would also be in trouble. So it's not about role exchange. It's really about keeping the quorum going, such that you have the ability to do joiner nodes and donor nodes, which you are otherwise not available to do while you keep your application running and your database running. Transaction conflicts, how are transaction conflicts handled? This again has not changed in Galera 3 and Galera 4. Transaction conflicts are handled such that if there is a transaction conflict, we look again at the time as to who applied it. And then if you set wsrep retry auto commit equals n, where n is a number, say 1 to 5 or something larger. So we typically just set it to 5. It'll retry that commit second time, third time, fourth time, fifth time. So before telling the client, look, I can't handle this because there's been a conflict. Now, how do we do that? Because we process each transaction on each and every node at any given time, and then we apply it across the cluster. So if you have a lot of updates, if you have a hot row, then this can be a problem. At which point, then we do recommend that you don't set updates through all 3 nodes. For example, you might only want to send it to 1 or 2 nodes. But realistically, the one thing we ask you to do before doing that is even basically just changing your schema such that you don't have hot rows. So you just change your data patterns, access patterns. Would you encourage the use of foreign keys in a multi-tenant Galera cluster? I would not discourage it. So you can use foreign keys. But again, I also know that there are many situations where foreign keys are completely disabled. So if you look at the likes of Facebook, I think they actually just get the policy to disable foreign keys inside of MySQL. So the choice is yours. We're not going to stop you. And without seeing your application or your schema, I can't tell you if foreign keys make sense for you or not. When would you consider just using one master for writes, trying to find out when certs failure and is a problem? Well, yeah, when you start seeing, when you can't change your application and you're having lots of conflicts, then it might make sense to start looking at 1 or 2 so-called master nodes to be writing. We don't really see this as a problem with a 3-node Galera cluster in most instances. And then, but then you also have to remember that, yeah, you could also then install a proxy afterwards. So we have multiple proxies available. It's Proxy SQL, MaxScale, I wouldn't use router, but it does work as well, HA proxy, and so forth. But yeah, it really depends on how many conflicts you're seeing and how you can't fix it. But again, we can help you with that. Can we provide documentation on monitoring wsrep flow control receive queue or flow control status? So yeah, we totally can. In fact, the documentation for monitoring flow control is in fact at our library. So if you just go to galeracluster.com/library and search for managing flow control, you will see an article here, including more about managing the replication state and so on. So yeah, please just go to the library, and if you find that you have more questions, you can obviously shoot an email over. All right, and we've got thanks for the answers. Great. So I think we might have also actually finished the question queue almost on time. Well, we're about 3 minutes over. So back to you, Sakari.
All right, thanks, Colin, and thanks for listening our webinar today. Stay tuned, there will be more to come. A lot of things happening this year with Galera Cluster and Codership, so we hope to see you again. Have a nice day and bye-bye.